For decades, Pluto was nothing more than a faint blur at the edge of the solar system, a tiny frozen world so distant that even the most powerful telescopes could barely reveal its surface. Many scientists assumed it would be little more than a cold, inactive ball of ice drifting in darkness. But everything changed when NASA launched the spacecraft New Horizons in 2006. Traveling faster than any spacecraft before it, New Horizons crossed billions of kilometers through deep space, using Jupiter's gravity to accelerate toward the outer solar system. For years, it remained mostly silent, waking only occasionally as it moved farther from the Sun than any planetary mission before it. Then, in 2015, the spacecraft finally approached Pluto, and what it discovered completely shattered old assumptions. As New Horizons drew closer, Pluto transformed from a blurry point of light into a real world filled with unexpected detail. Bright and dark regions appeared across its surface, and one massive heart-shaped feature immediately captured global attention. That region, later named Sputnik Planitia, turned out to be a gigantic plain of nitrogen ice unlike anything seen elsewhere in the solar system. Scientists quickly realized this was not frozen terrain sitting motionless for billions of years. The nitrogen ice appeared to flow and slowly circulate like glaciers on Earth. Huge polygon-shaped patterns stretched across the plains, likely created by slow convection beneath the surface. In Pluto's extreme cold, ordinary water ice becomes as hard as stone, forming towering mountain ranges several kilometers high around the icy basin. The surprises kept growing. Evidence suggested that glaciers had carved valleys across Pluto's surface, while strange formations hinted at cryovolcanoes that may have erupted slushy mixtures of water and exotic chemicals instead of molten rock. One enormous feature, Right Mons, rose high above the surrounding landscape with a deep central depression, suggesting Pluto may still possess internal activity beneath its frozen crust. Then came the atmosphere. Despite Pluto's small size and weak gravity, New Horizons discovered a surprisingly complex atmosphere made mostly of nitrogen, methane, and carbon monoxide. Even more stunning were the blue layered hazes extending high above the surface, glowing beautifully in sunlight. Pluto no longer looked like a dead dwarf planet. It looked like an active world with weather, climate cycles, and constantly changing surface processes. Its largest moon, Charon, proved equally strange. Pluto and Charon are so similar in size that they orbit a shared center of gravity located outside Pluto itself, making them behave almost like a double world system. Both bodies are tidally locked, permanently showing the same face to one another in an endless cosmic dance. Charon looked very different from Pluto. Its surface was darker and dominated by water ice, but the most mysterious feature was its reddish northern polar cap. Scientists believe gases escaping Pluto drift across space and settle onto Charon, where radiation transforms them into reddish organic compounds called tholins. In a sense, Pluto has been slowly painting its moon for billions of years. New Horizons also revealed massive dark regions on Pluto itself, including the enormous area known as Cthulhu Macula. These dark zones appear coated in complex organic material formed when sunlight interacts with frozen surface chemicals. The uneven distribution of these compounds hints at seasonal cycles and geological activity still shaping Pluto today. Perhaps the most astonishing possibility is hidden beneath Pluto's crust. Some evidence suggests a deep subsurface ocean of liquid water may still exist below the frozen exterior. If true, Pluto may have remained internally warm for billions of years, changing our understanding of distant icy worlds forever. But the mission did not end there. After passing Pluto, New Horizons continued deeper into the Kuiper Belt, a distant region filled with ancient icy objects left over from the formation of the solar system. Eventually, scientists selected another target, Arrokoth. When the spacecraft flew past Arrokoth on January 1, 2019, humanity witnessed the most distant close-up encounter ever achieved. The object looked unlike anything expected. Instead of resembling a typical asteroid, Arrokoth appeared as two flattened lobes gently fused together, forming a bizarre snowman-like shape. Its reddish surface contained organic compounds and methanol-based chemistry, while the surprisingly smooth structure suggested the two lobes merged slowly and gently during the earliest days of solar system formation. Rather than being shattered by violent impacts, Arrokoth appeared to be a preserved relic from the birth of the solar system itself. One of the strangest discoveries was its unusual flattened shape. Scientists still debate how it formed. Perhaps it once spun rapidly, or maybe conditions in the early solar nebula shaped Kuiper Belt objects differently than expected. Whatever the explanation, Arrokoth revealed that the outer solar system is far more complex and mysterious than scientists once believed. What makes New Horizons truly historic is not just the incredible images it captured, but the lesson it delivered. Before the mission, Pluto was considered a frozen relic. Arrokoth was barely known at all. Yet both worlds turned out to be astonishingly unique. The mission revealed that the Kuiper Belt is not simply a graveyard of icy debris. It may contain countless unexplored worlds with active geology, hidden oceans, strange chemistry, and histories stretching back to the formation of the solar system itself. In only a few encounters, New Horizons forced planetary science to reconsider decades of assumptions. Pluto became a world of glaciers, mountains, hazes, and possibly underground oceans. Charon became one of the strangest moon systems ever observed. Arrokoth became a preserved fossil from the dawn of planetary formation. The deeper New Horizons traveled into the frontier beyond Neptune, the clearer one truth became. The outer solar system is not a dead wasteland. It is a vast unexplored frontier filled with mysteries humanity has barely begun to understand. And perhaps that is the mission's most powerful discovery of all. The farther we travel into the darkness beyond the known planets, the stranger and more extraordinary our own cosmic neighborhood becomes. Even now, years after its historic flyby of Pluto, New Horizons continues drifting deeper into the darkness beyond Neptune, carrying with it humanity's curiosity into regions no spacecraft has ever explored before. Its journey has become something larger than a planetary mission. It is now a moving boundary between the known solar system and the immense unknown waiting beyond it. Far past Pluto, sunlight grows unimaginably weak. At that distance, the sun no longer dominates the sky the way it does on Earth. It appears only as an intensely bright star surrounded by endless blackness. Temperatures hover near absolute zero, and the silence of deep space becomes almost impossible to comprehend. Yet even there, New Horizons continues sending data back across billions of kilometers. The spacecraft is now traveling through the Kuiper Belt, a vast ring of icy remnants left over from the birth of the solar system more than 4.5 billion years ago. These objects are ancient survivors, fragments from a time before planets fully formed. Many have remained almost untouched since the earliest era of planetary creation, preserving clues about how worlds first emerged around the young sun. Before New Horizons, scientists could only study most Kuiper Belt objects as tiny points of light through telescopes. Shapes were uncertain. Surfaces were invisible. Entire theories about the outer solar system were built on guesses and indirect measurements. But the close encounters with Pluto and Arrokoth revealed a shocking truth. These distant bodies are far more diverse and complicated than anyone expected. Some may contain underground oceans hidden beneath frozen crusts. Others could preserve ancient chemistry dating back to the beginning of the solar system. Some might even possess internal heat sources capable of driving geological activity billions of years after their formation. The farther scientists look, the more the outer solar system resembles a collection of worlds rather than a field of lifeless debris. One of the most important discoveries from New Horizons was not a single image or geological feature. It was the realization that small icy worlds can remain active for astonishingly long periods of time. Pluto's glaciers, atmospheric hazes, and possible subsurface ocean forced researchers to rethink how heat and energy behave in distant planetary bodies. That discovery carries enormous implications. If Pluto can remain active so far from the Sun, then many other dwarf planets scattered throughout the Kuiper Belt may also possess hidden complexity beneath their frozen exteriors. Entire categories of ocean worlds may exist in darkness far beyond Neptune, completely invisible to us until spacecraft eventually reach them. Meanwhile, New Horizons itself has become one of the most distant human-made objects ever created. Every signal it sends travels for hours across space before reaching Earth. Communication delays are so extreme that controlling the spacecraft feels less like piloting a machine and more like exchanging messages with something drifting at the edge of another realm. Despite the distance, the spacecraft still performs scientific observations. Its instruments continue measuring dust, radiation, and the structure of the outer heliosphere, the enormous bubble created by the solar wind surrounding our solar system. These measurements help scientists understand where the Sun's influence begins to fade into interstellar space. Eventually, New Horizons may cross regions where the solar wind weakens dramatically, approaching the same mysterious frontier once reached by the Voyager spacecraft. Long after its planetary encounters are over, it could continue operating as a silent explorer of deep space itself. What makes the mission so powerful is how completely it changed humanity's perspective. Before New Horizons, textbooks often described the outer solar system as cold, static, and largely uninteresting compared to the inner planets. That image no longer survives.